All right, let's look at some non-linear systems. So not two lines. Now, in this, we are going to see, maybe there's one line in your system, maybe there's no lines. So we're going to look at a bunch of different types of functions in our systems. And it's not super important for you to know, like, oh, is this linear, is this not linear? Because you're going to either just use your calculator and you can see it, or you're going to just do some math. What is important for you to know is the difference of how to solve a linear versus a nonlinear. And the biggest thing is knowing that a nonlinear has an x squared, or has a square root, or has an absolute value. Linears have just like 3x. Y equals 5x minus 7. It should have two variables for an equation. And it's just two variables with no extra symbols. So not linear, linear, not linear, linear. Not linear, linear, not linear, linear, not linear, not linear, not linear, linear. Right? So linears have just x and y. Non-linears will have some other symbols or things on there. That's only important for you to really realize, because solving a non-linear is different than solving a linear. So in your last couple of lessons, when you solved your linears, you just had to do elimination or substitution. You could solve it pretty easily. Now, we're going to do graphing the same as we did before. There's just a couple of symbols I'm going to have to show you on your calculator. So we can still graph, eliminate, and substitute. However, elimination and substitution, you're typically going to have to factor or use the quadratic formula at some point. In how I am setting up this lesson. Now, there are going to be other nonlinear systems where even factoring or quadratic formula isn't going to work, and you would have to do something else. But we're going to focus in this lesson on ways that you could just end up factoring or using the quadratic formula, or graph if I allow you to graph on questions. So we'll start by graphing. Same as before, you have to have it solved for y. So down here, y equals perfect, but this one, we need to rearrange that one. Then if you ever have to take this square root to get y alone, which you probably won't have to do, just do keep in mind that there are the two solutions, one with positive and one with negative. So if you have to take a square root to get y by itself, you're going to have y equals the square root of whatever, and then y equals the negative square root of whatever. I am not going to go too much in depth about that right now, because I don't think there are any problems like that for you to worry about. But if you come across any, let me know. I'll go more in depth with you about that. Type both of your equations into your y equals in your calculator, or look at your graph. Same as before, second trace, intersect, enter, enter, enter. You do need to repeat those steps, though, in 5 and 6 for however many solutions you have. Previously, so far, you've only seen one solution. However, or no solution or infinite, of course. But now we're going to start seeing two solutions. So you're going to have to repeat that process to be able to get the second one. And I will show you how, when that happens, you will have to slightly move your cursor before you hit enter 3 times the second time. So our first equation is already by itself y equals, but our second one we need to rearrange. So since this is positive, you would subtract 5x from both sides, giving you negative 2y equals 4 minus 5x. And then you need to divide all of your terms by negative 2, since that is the number in front of your y. Reducing fractions, if you want to, you really don't have to. You could leave it exactly how it is on your paper. As long as you have y by itself, your calculator is going to do it for you. I am going to simplify. 4 divided by negative 2 is negative 2. Negative divided by negative is a positive. 5 over 2 does not divide or reduce x. So I'm going to type this first one in my calculator and the second one in my calculator. Turn it on, y equals. So it already has the y equals, so square root, which you know that button, it's this blue, and then you hit your little x squared. So second x squared is going to pop up the square root. Now, x plus 7 is all underneath your square root, so make sure it is all underneath your square root, x plus 7. See how that square root extended? Everything is underneath there. If you would have done square root of x, and then you arrow over and put plus 7, see how that 7 is not underneath the square root in this problem? This one is wrong. Don't type this in there. That's wrong. The first one is what you should have typed in. So square root of x plus 7. And then I've got -2 plus, and then alpha y equals, hit enter to get a fraction. 5/2, arrow over, and x. If you're having any issues or difficulties getting any of that typed in there, please let me know. You need to go graph so that you can see your graph. And you can see this come up, and you may or may not be able to see all of your solutions on your screen, but we need to just know if there are any more, and then we can go and find them. So if I look at this graph right here, it starts right here, and then it's going to continue. And then I have a line. These are only going to intersect here. If you pictured this line is going to continue to go down, but this is showing you that it stops right here. It's not going to come down anymore, or else it would show you that. If it did, then yes, there might be a second solution, but there's not. So I go second, trace, number 5. And since there's only one solution, all you need to do is enter, enter, enter. Your answer is 2, 3. All you have to do on that one, because there's only one answer. Now, next one. I do have a y equals, so that one is already set up. But my second one is not. Since my x is positive, I'm going to subtract x, giving me 2y equals 12 minus x. Dividing by 2 for every single term gives you y equals. Once again, you could just leave it like that if you want to. That is fine. I'm going to show you that. 12/2 minus x over 2. So I'm going to type in this equation, and I'm going to type this equation to y equals. So make sure you do clear out your old ones. Now here's a symbol I need to show you how to do on your calculator. Absolute value is there. You just can't see it yet. Absolute value. You're going to hit math. Hit math. And then arrow to the right. To where it says NUM. That stands for number. And then you're going to hit number 1. That says ABS. Stands for absolute value. And it pops up your absolute value bars, and you type in whatever you're supposed to inside. And if you had anything on the outside, you can arrow over to do that. So inside I have 3x minus 1. And that's all that equation is. Then I can come down here, and you can type in 12/2 as a fraction or use your division, up to you. Alpha y equals 12/2. Then I have a minus alpha y equals for another fraction of x over 2. I'm going to graph that. And I can see my two graphs coming up. I noticed that the first one made a V and the second one makes a line. Some of you have calculators that have color-coded graphs, which is actually really, really nice because you can very clearly see that this is maybe red and your line is maybe blue. So you can see everything that's red is one graph and everything that's blue is the other graph. So you can clearly see the differences. But if you have one like I have, it's fine. You just, as you watch it, well, it's not going to graph it now, but as you just watch it graph, it'll show you the two different graphs if you're ever not sure. So this one I do see has 2 solutions. I see it intersects twice. So the first time I'm going to do second trace, number 5, enter, enter, enter. Nothing else for that. And I get -2, 7. Now maybe you didn't get -2, 7 because there are 2 solutions and it maybe gave you the other one instead. And that's fine. You get the other one. I'm going to show you how to get your other one, whether it's the same as mine or it's the one I already have. I need to get this one. I'm going to do the first couple steps the same. Second, trace, number 5. But before I hit enter 3 times, I need to just move my cursor one way or another to get it closer to the other point. I need to move mine over here, so I need to move to the right. So I'm going to arrow to the right. I don't even need it to be on that intersection or close. I just need it to be closer to that one than the one I was already on. Once I'm there, then enter 3 times. No other moving. Enter, enter, enter. And it should come up. 2, 5. If it still gave you the one that you had already had, just move your cursor over more. Maybe you didn't move it over enough. It will do it for you as long as you move it. If you notice that maybe you should have another point, another solution, and you just can't see it on your graph or you're unsure or whatever, that's changing your window situation. And once again, I have said, I will always help you fix your window. All right, that's how you graph them. So now let's talk about how to solve using algebraic methods, because you're going to have to know how to do that, right? And I will also say that the ones we're about to solve, they are going to be very difficult to check with your calculator just because the type of equations they are. So just be aware of that. Those of you who are familiar with Desmos, you may absolutely feel free to check those answers on Desmos as you're working with your practice problems, but not while you take your knowledge check. So just be aware of that. So, algebraic method. You may use elimination or substitution. However, elimination only works if you have pairs of variables that have the same power. So if you have an x and an x squared, you can't eliminate those. That's not possible. So most of these, it's not actually going to work to do elimination. I will show you, though, that there are some examples, and I'll show you some of those that you can. Substitution is usually going to be the better choice. If you use substitution, then you're going to solve one of the equations for one of your variables. But keep in mind, you have to get that variable 100% by itself. So if you have an equation like y equals 2x plus 5x squared, then you have an x and an x squared, and you're not going to be able to get x by itself. Okay? I'll show you some of those examples so I can explain what I'm talking about. You're then going to use an appropriate algebraic method to solve. You are likely going to have to factor or use the quadratic formula at some point. Keeping in mind that once you have solved, this is not on the note, so once you have solved, you do need to take those and plug them back in to get the other part of your coordinate point. You are going to solve for one of your variables. You're going to get the x values. Well, now you need to find the y values. Or you have gotten the y values, and now we need to find the x values. That's the same as before. So let's go through some examples. It's going to make this a little bit more understood. You're going to understand better what I'm saying. So first things first is you can always use substitution, but you can only sometimes use elimination. So I will show you in some of these examples the elimination method just so you can see it. But then I will point out on ones where you can't use elimination, and then we'll definitely do substitution on those. If you are a substitution person, you prefer substitution, then do substitution. Don't follow my elimination example. Do substitution. I am going to point out that example number, one moment, I'm looking at my notes here. Example number 2, I use substitution. So if you want to see, I'm going to use elimination and then I'm going to use substitution. If you want to do substitution only, start with example 2, watch me do it, and then try and get example number 1 done on your own. Or if you need help with it doing substitution, which I'm not going to do in the video, then ask me and we can go through it together. All right. So if you're an elimination person, definitely start with number 1. But if you're substitution, maybe start with number 2, which is actually going to be the start of the next video. So I would just skip to that video and come back to number 1. But up to you. So with elimination, you have to have things stacked in order with your like terms. So I can do elimination in this problem. By the way, if I did substitution, I'm just going to take, I have y equals, I'm going to take this 5x minus 9 and plug it in for y equals. If I do elimination, my y's are stacked, but notice I have an x squared here, and this is not an x squared. Now I have these x's, they're not stacked, and then I have this constant. So I need to rewrite both of these so that I have y equals, I'm going to put 3x squared minus 7x plus 0. So I have a y, an x squared, an x, and a constant. And that's what I'm going to do for this one. Put it as a y, an x squared, which I don't have any, so 0x squared, and then your 5x, and then your constant, your minus 9. So now everything is stacked, and I'm going to eliminate. Now, you aren't going to be able to eliminate the x's because you have x squareds and x. All you're going to be able to eliminate are your y's because you have just y. So this is where elimination only sometimes works. If you have x squared and x, you cannot eliminate those. So in this example down here, I have squares on both of the x and the y. I can't eliminate. I cannot use elimination here. I can here. Keeping in mind that you need opposites, but these are currently the same. But they're the same, so all I need to do is switch all of the signs. So I can make this a negative y, negative 0 is still 0. I can make this a negative 5 and make that a positive 9. Now I can add these together. 1 plus negative 1 is 0, and you need to write 0. You do not need 0y, because 0y is just 0, and that's actually good because you want your y's to eliminate, which they did. Now 3 plus 0 is 3x squared. Negative 7 plus negative 5 is negative 12x, and 0 plus 9 is 9. Okay. You have only x's now, which is good, but you do have an x squared and an x. So this is where you're going to factor, complete the square if you want to, or quadratic formula to solve for x. I'm going to point out that all three of these terms can be divided by 3. I'm going to do that first because whether you, in any of the three options, it's going to be easier because you're going to have smaller numbers. So if all of your numbers can divide by something, I would do that. And that's just going to go away. Like it just disappears. Now, I didn't do it over here because 0 divided by 3 is 0, but you would also need to do it here if this wasn't a 0, FYI. Now I'm going to factor or quadratic formula. I'm going to factor because there's no number in front. So when I factor this, 2 parentheses, I need two numbers that multiply to be 3 and adds up to be negative 4, which would be negative 1 and negative 3. Multiplies to be positive, adds up to be negative 3. Or sorry, negative 4. And this is set equal to 0. And then you take this parenthesis and set it equal to 0, and this one set equal to 0. So you're going to flip your signs. So this is going to be x equals 1, and then x equals 3. This tells you that you have two answers. So I'm not done because I now need to find the y values, and I'm going to have two y values. I'm going to have two solutions. I can find them by plugging in 1 into x in the first equation or in the second equation. I'm going to use the second equation because that would just be y equals 5 times 1 minus 9. Just plugged 1 in for x. 5 times 1 is 5. 5 minus 9 is negative 4. So that answer is 1, negative 4. And then I'm going to repeat the same thing. I'm going to use the same equation. 5 times 3 minus 9. 5 times 3 is 15. 15 minus 9 is 6. So that answer is 3, 6. Those are your two solutions. Bell rang. Next video is going to start with number